Hello, welcome. In this tutorial we're going to explore the concept of using a one-dimensional array to store a collection of objects and manage that collection by defining a class that maintains that array within it. So we're not going to use the main method to store the array. Instead, to begin with, let's say I've got a blank main Java, but I've also imported this candybar.java class into my code, so it's here all within the same package, and I haven't changed anything about this candy bar from what we've done earlier. It's defined as it was before. But let's right click and create a new Java class. I'm going to call this a candy collection, and we're going to generate this, just a blank class to begin with, and I'm going to use this candy collection class to maintain a array of candy bars that I'll call bars. In addition, I'm going to want to store how many bars that I have in my array, because my array is going to have a capacity, but the array won't be completely filled at all times. So I'll use this current count to maintain that. So bars is my array of candy bar, and current count will be my integer, which represents how many bars I have in my collection. I'm also going to maintain a total calories private attribute. Okay? And every time we add a bar, we'll just increment that total calories as well. Let's create a constructor for this class. So we've got a public candy collection, and if there's nothing that's passed into this constructor, I'm just going to say that bars is equal to a new candy bar array, and let's default it to size 5. Current count is going to be equal to 0 because I don't have any candy bars in my collection yet, and total calories is also equal to 0 because I don't have any candy bars in my collection just yet. Let's create a simple getter for the total calories. Okay, simple enough. And let's implement the toString function as well for this class. I'm going to save us some time, and I'm going to paste in some code that I've written earlier outside of this tutorial. Just to save us some time, there's really nothing interesting or new going on here. I do my @override public string toString function, so I'm using my @override marker to denote that I'm explicitly overriding the toString function of the object class. I need to resolve this decimal formatter by fixing the imports. Okay, that's going to add the Java text decimal format to the top here. And then I've got a string called report that I'm going to increasingly build, showing how many bars I have in my collection, how many total calories I have in my collection. I'm going to also display the average calories by dividing the total calories by how many I have. And I typecast total calories as a float because you'll notice that the current count and the total calories are both integers. So I could just do integer division, but if I actually want a floating point value, then I can use the float typecast here. And then what is interesting about this is also in my report, I'm going to list all of the candy bars that are listed in my bars collection. So here's my array called bars of type candy bar, and I'm going to iterate across all of them and just output the candy bar, each candy bar in that collection. And since the candy bar has the toString function defined in it as well, then it's going to do whatever work it needs to do to display that candy bar. Okay, so this gets us going. We have our private attributes, and most interesting is the array of candy bar here. I have my constructor that allocates memory to hold up to 5 candy bars, and then I have my toString function that I have overridden. Okay, now let's do some work to actually allow my collection to display, let me do the work now to add the ability to add a candy bar to the collection. So this is going to be a public void method. We're going to call this add candy bar. And if you pass me a candy bar, I'll call that underscore new candy bar, then I'm going to add that to my bars collection. Now this demonstrates why I need to maintain the current count. So current count initially starts at 0, and every time we add a new bar into the collection, I'm going to increase current count by 1. So current count marks the first cell in the array that is open and available to insert the new candy bar into. Okay, so here I'm just going to take this candy bar in, and I'm going to assign the first open spot in my array, the bars array, to be this new candy bar. I'll then tell the total calories to go up by the new candy bar dot get calories. Right, so we'll use the getter or the accessor for the calories of the candy bar and increase our total calories by that. And don't forget, we need to increment our current count to denote that we have a new candy bar that we've added. Okay, this looks good and it'll do the work to add the candy bar, but there's something that we're missing here, and that is that what happens when the array is full. So before we can insert the candy bar, we need to do some work to say, hey, if the array is full, we're going to need to allocate new space for the array and copy over what's already there into this new space. Essentially, we're going to grow the collection. And what's nice about this is that since the array is private and inside of this candy collection, our user, or in this case main, of this candy collection can be completely ignorant as to all of the work that has to happen to insert and to manage the data. Okay, so just be aware that we're going to need to check the size of the array and see if it's full. Okay, I'm going to just denote that with a comment here, because for right now, by default, we have enough room for 5 candy bars. So we can add candy bars, no problem, up to 5 before we run into that issue. So we're going to come back to that and deal with that in a moment. But first, I'd also like to overload the add candy bar method, and instead of just taking in a full already realized candy bar, perhaps we want to give the user the ability to take in a string for the name, and integers for the calories, a double for the weight, and a double for the cost. So I'm going to pass all of these values in, and then I want to create a new candy bar based on that. The work's going to be almost identical to what we just did. The difference is going to be that I don't have this underscore new candy bars. I'm going to say that I want a new candy bar based on the name, the calories, the weight, and the cost. And then now what's nice is the constructor for the candy bar is going to do all the work of establishing this new candy bar object, and then we're going to place that here into our bars collection. Alright, the other issue that we have here is that the new candy bar doesn't exist, so we can use the underscore calories, because we actually passed that in as a property, or an attribute I should say, right here, and that's the only difference that we're going to have for this method. Now realize that we're still going to have to check to see if the array is full and do some work if that's the case. But for now, we can add up to 5 candy bars without any problem. So let's go back into our main, and let's make use of our candy collection by creating a new candy collection, and we'll call it snacks is equal to a new candy collection. This is just instantiating the new class we defined here that has the private one-dimensional array in it. Okay, and then we can make use of the snacks. We can say something like snacks.add candy bar, and let's say we want a Snickers added, and the calories for the Snickers is going to be 400, and the weight is going to be 2.01, and the cost is going to be 1.25. Okay, so I'm just going to add the Snickers bar. This is invoking one of the new methods we just defined, this add candy bar, and then we can do a system.out.println on snacks, and it's going to run the toString function of our candy bar collection. So if we run, what we'll get is another candy bar has been created. This is the static method that increments the ID and so forth that we've already done in our candy bar. This is the first candy bar to be created, and so that is when we invoked this add candy bar. It goes into the candy collection, and add candy bar creates a new candy bar. Okay, that's what this line comes from here. All right. Then, back in main, we said system out println on snacks, and snacks is our collection, so all of this right here is the output that we get for that. So you'll see that we say my candy bars, we have one bar, 400 total calories, and the average calorie is 400 because we've only got one candy bar, and then we've only got one Snickers in our candy list. So let's go up here and add some more. Snacks.add candy bar. Let's add a Zagnut that has 295 calories and weighs 3.03 ounces, and let's say it costs $1.45. Now if we run, we should see the output will show that we have 2 candy bars, and it looks like everything's working quite nicely. We can continue this up, continue this on, and this time I'm going to pass it Almond Joy, which has 315 calories, 1.9 ounces, and costs 75 cents. And again, if we run, you see everything's working quite nicely, that the candy bars are being added. Let's add another Snickers. Let's say this one is a supersized Snickers with 600 calories, weighs a bit more than the last one does, and it costs a little bit more as well. Okay, so this is going to bring me to 4 entries. Let's do another one here just to demonstrate that we can pass in a candy bar object. So let's say we've got a Milky Way with 335 calories, weighs 275 and costs 90 cents. And then I can add candy bar. Snacks.add candy bar. Notice one of the overloads is that we're taking in an entire candy bar. So the add candy bar, I can pass all these different values, or I can pass an entire candy bar. And if we run, what we'll get here is we've got a Snickers, a Zagnut, an Almond Joy, a Snickers, and a Milky Way. Looks good there. And you'll see that we've got 5 total bars. Now if we add another bar, the problem is going to be that we're going to get an array out of bounds error. So let's just give that a try here. So we'll say we're going to add another Milky Way with 330 calories, 201, and costing 55 cents. And we should get an error because we've now exceeded the capacity of our array. Okay, problem. We've got an array index out of bounds problem that's just happened here. Okay, so let's fix this. Let's go back into our candy collection. We said earlier that we need to check the size of the array and see if it's full or not. So let's do this now. And we know that the array is full if the current count is equal to the length of the bars. The bars is my array, and the length is going to report to me how many entries, or the size or the capacity of that array. So if current count is equal to that, then we know that the entire array is full. So let's do something called increase size. And we're going to have to, of course, write this, but we'll put it in both the add candy bar for the taking in the single candy bar and the add candy bar definition when we take in all these values. So now we just need to define the increase size function. I'm going to make this a private function because no one else should be able to adjust the size of the candy bar collection. I want the internal workings to make that happen. And the way we're going to pull this off is by creating a new temporary candy bar array. And we're going to tell it I want this thing to be twice the current capacity. So I'm going to take the bars.length, which tells me what's the size of the current array. I'm going to multiply that by 2, and that's going to be how large I want this new array to be. So temp is this new space that's twice as large as the current bars array. And then I can just do a copy from 0 to bars length. and say that the temp at position I is equal to the bars at position I. And what this will do is it'll copy, one for one, it's going to copy all the values from the bars array into the temp array. That's exactly what we want to have happen. And then we're going to make bars refer to this new space. So I've got this space called bars currently. I allocate a new space called temp. I copy everything out of bars into temp, and then I make bars point to this new space. You might be thinking, what in the world is going on here? Why do all this work if bars is going to be what's left over in the end? The difference is that notice at the end of these 4 lines of code that bars now has a capacity twice what it did before we ran this code, which is really quite nice. That's exactly what we want to do. And just to prove that it's worked and demonstrate that this has happened, we'll say that the array has been resized to bars.length. And if you remember, we by default set up the candy bar size 5. So now if we add that 6th candy bar, we should see this output occur and say, hey, we've now resized the array to be of size 10. So let's run this, and you'll see that we get the array has been resized here to 10, and now we have 6 candy bars. All that information is printing out quite nicely. So this is good. We're able to grow our array, and in the main program, it's completely ignorant. It doesn't know that this has occurred at all. We don't have any problem. We haven't had to change the code that we wrote by modifying and improving our collection class. It's just going to automatically work out better for us then. There's a minor problem with this though, in that when we're creating an array and then we manually copy it over, this is pretty error prone. Maybe we missed one, or we're going to go above or beyond the proper array bounds. So there's actually a better way of doing this. I'm going to comment this code out to indicate that I don't want to do this explicitly. But a better approach would be to say something and use a copy of function that's built into Java. So I still want my temp array, but into this I'm going to use the arrays copy of, okay, and I'm going to copy it from bars, and I want to do bars.length times 2. Okay, this is going to pull off the exact same thing. It's just going to use this copy of function, and I just need to resolve this now. Fix the imports. It's going to add java.util.arrays, and then this all works out. Now I want to show that this does exactly what we did before. We're just using the copy of function instead of manually doing it ourselves. So if we run this, we should get the exact same output, and you see that the array has been resized, and you see that everything was copied over perfectly just as we would expect. Okay, so everything's going along pretty well here. Let's add some new capability to our candy collection class. Let's add the ability to search for a particular candy bar and get its index as to where it might appear. This is going to return the index of where the candy bar occurs, so it's going to return an int. And call this method getBar. And I'm going to take in a string called name2find, which is the name of the candy bar that we're looking for. And thus we can't just pass in a candy bar object. We need to pass in one of the properties of the candy bar and then search for using the getter to see if we have a match there. So we're going to do a simple loop across the entire collection. Notice I'm using the current count because I don't want to iterate across the entire array, because some of those values are going to be null. In the case where I've only inserted one candy bar, for example, I've got 5 spots but only one actual candy bar. So I don't want to look at the spots at the end of that array that are null. I just want to look at the ones that have been filled in, and current count gives me that upper bound. So now I'm going to do my comparison to say if the name2find equals, because I'm doing a comparison here, equals the bars sub I dot get name. Okay, so what I'm doing here is I'm saying I've got this current candy bar that I'm looking at because I'm going to be iterating across it. I'm doing a linear search here. So I'm looking at the ith bar, ith candy bar, and I want to get its name, and I want to see, is it equal to this string that I've brought in, this name to find? And if it is, then I'm going to return I, meaning I just found a match, so I'm going to return I, which is the index, and that's the point of this. I want to return the location in the array where this occurs. Okay, and that's it. So if I make it out of that for loop, then I know that I didn't find a match, and I'm going to return -1. Now the only way to get down to here is if I never found a match and I exhausted all of my possibilities. So I'm going to return -1, which is a good example of a valid kind of error return value, showing that if the candy bar existed, it would be at an index starting at 0 and going up. So -1 would be an impossible location for this to be. Okay, so let's go back into main then and make use of this getBar function. Let's say we want to find the location of Three Musketeers, right? So no, we don't have a Three Musketeers yet. Let's add a Three Musketeers in. I think we need some more snacks in our collection. Let's add a Three Musketeers. And how caloric is a Three Musketeer? Let's say it's got 320. It's kind of standard. Oh, that is a tremendously huge Milky Way. Let's bring that weight down to 2 instead of 20. Not that it really matters, but that's a tremendously large candy bar. Okay, and so we've got a Three Musketeers that has 320 calories, weighs 2.02 ounces, and the Three Musketeers is going to cost us 99 cents. Okay, so let's look for it. Let's say that we want to find exactly where this thing is. So we're going to do system out println the location of the Three Musketeers is, and to that I'm going to look into my snacks collection, and I want to invoke my getBar, and I'm going to pass it Three Musketeers. Now I need to be really careful here and make sure that I'm spelling this properly. Otherwise I'm going to have troubles. I don't need that close paren there. Okay, so Musketeers, Musketeers spelled properly. I insert it as this, and I'm searching for it as this. So if we run, the location of Three Musketeers is not there because I misspelled it. It's Muxeteers. I did that on purpose. I didn't know if you caught me trying to emphasize the different spellings, but this shows that if I misspell it, or I'm looking for something that's not in the collection, that location is going to come back as a -1. If I spell it correctly, and just to be sure, you can highlight that and paste it down here, but it's already a match, but there you go, just to make sure. And now if we run, we should see that the Three Musketeers has a location of 6. It's actually the 7th entry, but remember we start counting at 0. So our getBar function here inside of Candy Collection is working quite nicely, and if I pass it a string, it's going to return to me the location of the candy bar. I can also get a bar based on the index. So perhaps I want to pass in an index, and I want you to give me the actual candy bar. So I want the 0th candy bar, for example. Okay, so you give me an index and I'm going to give you a candy bar. And into this, I first need to check to make sure that the index is less than the current count. So if you ask me for the millionth candy bar, then that's perhaps going to be too large. I don't have a million entries. But if the index that you're asking me for is less than current count, then I'll simply return bars of index. Not bards, we're not singing, we're maintaining candy bars. Okay, so return bars of index, I'm just going to give access to the candy bar at that index spot. Otherwise, if you gave me an index that is too big, then I'm going to return null. And I could also do some check here to say, is the index at least 0, if I want to be really proper. So if the index is greater than or equal to 0, and the index is less than current count, then I know you've given me a valid index and I'll return it. Otherwise, I'm going to return null here. Okay. If we go back into main, and I can say something like system.out.println snacks of get bar, and I'm going to say get bar and pass it this index to say I want the third candy bar, or at index 2. So I'm going to print that out. And I could say something to the effect of the bar at index 2 is equal to get bar of 2. Okay, so let's run this and see what we get. And the bar at index 2 is the Almond Joy. So Snickers, Zagnut, and Almond Joy. Aha, there we go. So our get bar function that takes in an int is going to work as well as the one where we pass it a string. It's a good way of getting access to a particular value in our collection. The last thing I want to add into my candy collection is the ability to figure out where the most caloric candy bar is. Okay, so this is going to be a new function down here in my candy collection. I'm going to return a reference to the candy bar, get most caloric bar, and it takes no parameters. And the purpose of this function is to determine which candy bar has the most calories in it. So rather than searching on the name like we did here, perhaps we can search on the calories information. So the first thing we're going to need to do is determine, are there any candy bars in the collection? So if the current count is 0, that means there's no candy bars in the collection, and we'll just return null. Otherwise, I'm going to create a new reference called return bar of type candy bar, and it's going to be default the 0th candy bar. So when you're doing a search, oftentimes it's advantageous to use the first entry in your collection as the default return value, and then prove otherwise if you need to modify that. So in this case, I'm going to assume that the most caloric candy bar is that 0th candy bar, and then I'm going to loop starting at 1 and going so long as I is less than current count, standard array on my collection, and if the bars at I dot get calories is greater than return bar get calories, meaning is the calories at this new spot I'm examining larger than the calories on this bar that I think is the largest I've seen so far, then I need to return, I'm going to update my return bar reference to be equal to the bars sub I, or the one that I just saw. Okay, so this loop is going to iterate across all of the candy bars in the collection and determine which one has the largest calories count, and then at the end of this loop we have this reference return bar that is going to be pointing to the candy bar with the largest number of calories. Okay, so do some checking, make sure that you have some candy bars in the collection, initialize the most caloric to the first in the collection, and then traverse the entire collection to see which one has the most calories. Back here in main, let's create a new reference, candy bar, we'll call it big one. And I'm going to method, and after I've done this, big one should be pointing to the most caloric bar. So let's check this out. The most caloric bar is big one. And if we do that, we should get the last thing down printed here should be, in this case, if we look through here, it looks like we've got this extra large Snickers with 600 calories, so that should be what comes out at us here. The most caloric bar is, in fact, this Snickers with 600 calories. Quite nice. Okay, so now we've got the ability to search not just by the name, but iterate across the entire collection and determine which one of these candy bars has the most calories. Now in review, what you should get out of this tutorial is the ability to define a new class that maintains a private array inside of it, initialize that in the constructor to be of some size. The toString function we overrode and wrote out how to display and iterate across the entire collection. We were able to add candy bars either as a reference or by all of these different values. And then the key was to make sure that we increased the size of the array if we needed to, if the array was full and we didn't have any more room for the new candy bar. So we wrote this increase size function that increased the capacity and doubled the space in the array, accommodating new candy bars to be put into it. And then we finished off by writing these methods getBars that were either searching on name or were returning a particular candy bar by its index or location in the array. And finally we had this getMostCaloric bar that did a search based on the calories information of each bar. The key there is to realize that the objects themselves that you're storing in your array might have private attributes, and if you wanted to do a search on them, then you're going to need to go through the accessor or the getter. And that'll do it for this tutorial.